So in a previous session, we discussed regarding the parabolic antenna. So let us continue our discussion with respect to the next aspect, that is the Yagi Uda antenna. So Yagi Uda antenna is named after two people. That is one person by the name S. Uda, who was the main person who invented this antenna, and few of the translations were done for this antenna with the help of Professor H. Yagi. So therefore this antenna is named after these two people, that is Yagi Uda antenna. Now let us see what are the main features which are associated with Yagi Uda antenna. So here when we observe antenna, we see that there are three main aspects which are associated with the Yagi Uda antenna. One is termed as the reflector, one is termed as the driven element, and the third one is termed as the director element. So let us look at the image and try to see what are these elements. So here we can observe that there is an antenna which is represented. This is actually a Yagi Uda antenna. Now in this case, we can see that there are some rod-like structures which are present. So these are the reflectors. And there is another rod-like element at this end. This is actually, these are the directors. This is the reflector. And this hanger-like structure, what we are observing is the lambda by 2 dipole, or sometimes we term it as a folded dipole. This is the folded dipole, or it is the driven element. So when we observe these kind of structures, this is actually a Yagi Uda antenna in which we have a reflector and we have multiple directors. So here we can see that we are having these elements which are actually the directors. So from here to here we have multiple directors. And here we have another structure which is the reflector. And this part what we are observing is the driven element, or the lambda by 2 dipole, or the folded dipole. So these are the elements what we can observe in a Yagi Uda antenna. So the same thing is represented over here. So here we have a reflector. Here we have a driven element, which is a folded dipole. And at this end, we have the director. Now, when we make an association of the length, that is, we make comparison of the length with respect to the driven element. So we observe that the length of the reflector is slightly greater than that of the length of the folded dipole. So it is greater than lambda by 2, since the dipole what we are considering is a lambda by 2 dipole. It's a lambda by 2 dipole. And the length of the this dipole will be around lambda by 2. When we identify the length of the reflector, it will be greater than that of the dipole length, or the folded dipole length. And when we consider the length of the driven element, its length will be lesser than lambda by 2, which will be lesser than the length of the antenna, that is the driven element which is present over here. So this is how the lengths are associated with each other, that is of the reflector, driven element, and the director. So since there are only three elements in this, we term it as three element Yagi Uda antenna. We specify it as three element Yagi Uda antenna. Now, what about the most commonly used Yagi antenna? So in this, we have total 6 elements. So in the 6 elements, we have one reflector, one driven element, and total 4 directors. So what is the purpose of the reflector in Yagi Uda antenna? Its purpose is to reflect the AC signal which it receives towards the director. So that is its main purpose. It has to reflect the received AC signal towards the director. And the main purpose of the directors is to increase the directivity of the overall Yagi Uda antenna. And whenever we make a observation of the radiation pattern associated with the Yagi Uda antenna, we can observe that the radiation pattern is unidirectional in its nature. So this is how it might appear. That is, it will be having a maximum in only one direction. So therefore, we specify it as a unidirectional antenna. So now, in association with this, let us see what are the specifications associated with the Yagi Uda antenna. So apart from that, what we observe is whenever we consider a reflector, it reflects the AC signal towards the director. And so because of which, if I try to analyze